Now we're into part 2 of our video with the car on the incline. It's a bank road and it's going around a circle. We did the sum of forces in the x direction equals force centripetal, ending up with mv squared over r equals force normal sine theta plus force normal mu s cosine theta. We then said the sum of the forces in the y direction equals 0 equals force normal cosine theta minus mg minus force normal times mu s times sine theta. We did a little factoring and ended up with an equation, that said mg equals force normal times parenthesis cosine theta minus mu s sine theta. Well, it's now time to solve that expression, and here we go. So let's solve for force normal. So force normal is going to equal mg, and that's going to be then divided by cosine theta minus mu s sine theta. I'll extend my line so we're not confused. And then what I'm going to do is where I see force normal in this equation, I will put that expression. Okay, so let's get started. I've got mv squared divided by r is equal to, let me change my colors here. So where I see force normal, I'm going to put then, which is right there, mg divided by cosine theta minus mu s sine theta. And let me change back. On top then we have sine theta. It's going to be plus, I'm going to again plug in force normal there from this expression. Let me change colors again. That'll be mg divided by cosine theta minus mu s sine theta. Completing that up there. Let's complete up, and there's going to be a mu s cosine theta here. Okay, let's see what we can do. Maybe simplify things a little bit, and then we're going to solve. I'll probably just solve for v squared here. Okay, and then we'll probably be able to factor something out as well and see what actually happens. So I can see that an m is going to cross off here. Okay, that looks good. And then I can multiply r to the other side. And I'm going to have an expression, rg. And we're going to multiply that by parenthesis sine theta plus mu s cosine theta. Make sure I complete that theta. Divided by parenthesis. Let me redo that just a little bit better so we can see that a little bit better there. Okay, so I'm going to use a nice flat line there to make that easier for us to see. Okay, so let's complete that up. And what's on the bottom here is our common denominator. That'll be cosine theta. Okay, minus mu s sine theta. And what does that equal? That equals our velocity squared. Of course, I could square root both sides, but that's good enough. I just wanted to make sure you guys could see the derivation of that equation. So now we have components of normal force and components of friction force helping this car to stay going around a circle of a banked incline. And velocity squared is going to be the maximum velocity that this car can go along based on the radius of the curvature of the track, that is. Notice how if radius increases, the velocity will increase. If gravity force increases, so can the velocity. So these two factors are really important in terms of a car's ability to travel around a circle. We also see that the coefficient of static friction also plays in overall as well.